You know, it's crazy, but the difference between a B and an A star in Cambridge biology so often comes down to just one incredibly specific and honestly heavily misunderstood topic. And that's transpiration, evaporation, and the diffusion of water vapor. Welcome to this explainer. If you've ever felt like your core biology knowledge is absolutely rock solid, but your exam grades just kind of aren't matching up to the effort you're putting in, well, pay close attention. Today, we're going to deconstruct exactly how examiners think and, more importantly, how they actually award those marks. Let me ask you a question real quick. Are you losing critical exam marks simply because you forgot to show you're working? I know, it sounds super basic. It sounds exactly like something your math teacher would yell at you about back in middle school, right? But I promise you, failing to make your analytical process visible on these transpiration questions is literally the #1 way students silently drop grade boundaries. You could understand the whole physiological mechanism of water potential gradients perfectly, calculate the right final number in your head, and still lose out on major points. No way, right? But it happens all the time. Okay, let's dive into this. Consider this direct, urgent alert straight from the Cambridge examiners themselves. Even if your final answer is wrong, method marks can save you. Guys, this isn't just friendly advice. This is a massive, flashing neon sign. They are actively hunting for reasons to give you points. If your logical process, your step-by-step calculation, or your formula structure is just visible on the page, they can and absolutely will award method marks. A little calculator slip up at the very end really shouldn't cost you the entire question. But a blank working space? Yeah, that is a guaranteed 0 for that step. You've got to prove exactly how your brain got to the answer.
Moving right along, let's hit our first major section here, core concepts, and exactly why ordinary revision fails. So a lot of students think studying just means rereading the textbook until their eyes glaze over. But simply memorizing definitions of stoma, guard cells, and the cohesion tension theory, it's just not enough to meet those 9,700 syllabus objectives. Rote learning really only covers the bare minimum. In fact, here are the top 3 examiner warnings pulled straight from the principal examiner reports. Number 1, confusing cause and effect. I mean, did the stomata pores close because the rate of transpiration dropped? Or did transpiration drop because the stomata closed? It's an absolutely vital distinction. Number 2, forgetting your units and standard terminology. And number 3, and honestly this is a really big one, writing generic answers that just aren't specific to the context provided. See, examiners don't want a brain dump of everything you've ever learned about transpiration. They want to know what is happening to the specific plant in the specific experiment they've put on the page right in front of you. So what does top-tier performance actually look like? Well, A-star mastery equals a connected, conceptual understanding that you can immediately transfer to completely unfamiliar contexts. It's like a giant puzzle. Top-scoring candidates don't just recite isolated facts about xylem vessels. They demonstrate how those biological principles apply to some rare plant species they've literally never heard of before, under some totally bizarre experimental conditions. They see the underlying matrix of the biology, you know?
All right, now that we know the common pitfalls, let's pivot over to the solution. Section 2, the methodology, securing the method mark. Think of me as your personal subject specialist today. We're going to walk through the exact technical framework you need to completely bulletproof your exam answers and basically force the examiner to give you top marks. Now, in just a moment, I'm going to show you a hidden examiner clue that changes your answer completely. It's a tiny detail most students skim right past. But first, you absolutely need the framework that makes that specific clue obvious. Because without this framework, you'll just be staring at a complex data table feeling, well, completely overwhelmed. Okay, here is your 5-step procedural framework to safely navigate any complex past paper problem without the cognitive overload. Step 1, deconstruct the question. Highlight what is actually being asked. Step 2, extract the relevant data directly from the stimulus materials. You know, the graphs, the tables, the text. Step 3, select your analytical framework or statistical test. Step 4, execute your answer with really clear, visible notation. And finally, step 5, present your final conclusion with completely flawless biological terminology. So the crucial point is, you need a way to actually remember this when that exam panic sets in and the clock is ticking down. Enter DCEP. It's a super simple memory hack using the first letters of those steps. Deconstruct, extract, select, execute, and present. DESEP. The very second you sit down and open your paper, you can literally just write DCEP in the margin right next to a tough data analysis question. Keeping this mnemonic in your head will make absolutely sure your answer has a rigid, totally fail-proof structure. Let's see how DCEP actually works in practice, specifically zeroing in on that select step. When you're dealing with transpiration data interpretation, picking the correct analytical framework is make or break. If your goal is to compare means between two different plant groups, you select a t-test. If you're dealing with categorical genetic data, you'd select chi-squared. But if you're looking at continuous relationships between variables, like say how increasing wind speed affects the rate of water vapor diffusion, you absolutely must select a correlation test. Choosing the wrong statistical approach basically means losing the thread of the entire question right out of the gate.
Moving right along to Section 3, Interactive Viewer Challenge, Spot the Error. It's time to actively apply this DCEP framework.
Take a really close look here. On the left side, we have a flawed student answer. Now, it reads well, sure, but it relies completely on generic textbook facts about evaporation. On the right side, though, we have a top-band answer. I'd highly recommend just pausing this explainer for a few seconds to see if you can spot the fundamental error in the flawed answer. Ready? Okay, so the flawed answer basically just dumps information. It totally ignores the graph. The top-end answer, on the other hand, actively evaluates the specific evidence given, it questions the assumptions made in the experiment, and it justifies every single decision using extracted data points. It doesn't just say, oh, water evaporates. It specifically says, as evidenced by the 15% decrease in mass shown in Table 1, the rate of transpiration, see the difference? That right there is a real game changer.
And the absolute most important takeaway here comes down to a single number. 0, because 0 is exactly the number of marks you're going to get if you just list those generic facts instead of actually extracting relevant data from the specific stimulus materials they gave you. Listen, the examiner already knows that you know what transpiration is. What they're testing is whether you can figure out why it's happening at a specific rate in the totally novel scenario they've just dropped on your desk. All right, let's wrap this up with Section 4, final recap and the diagnostic cliffhanger. We have definitely covered a lot of ground today, so let's consolidate everything to make sure you can walk into your next biology exam with absolute strategic clarity. Here are your 3 non-negotiable takeaways to guarantee high marks on these transpiration and evaporation questions. First, show all of your working, every calculation, every single step. Secure those method marks even if your final math is a tiny bit off. Second, use the DCEP memory hack. Deconstruct, extract, select, execute, present to give your answers a bulletproof structure. And third, always justify your conclusions with hard evidence and specific data points pulled directly from the provided materials. Applying these strategies really takes practice for sure, so make sure you're actively using them on past papers. And to make sure you never miss one of these strategic breakdowns, go ahead and subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We're constantly deconstructing the syllabus so you don't have to. But wait, let me leave you with one final, kind of dangerous thought. What if you do everything we just talked about absolutely perfectly? I mean, your method is visible, your data extraction is flawless, your DCP structure is completely locked in, but you still drop an entire mark band. Why? Well, what if you use the wrong command word? Like, what if the examiner asked you to describe, but you spent 10 whole minutes trying to explain? Actually, scratch that. That tiny linguistic trap is literally the hidden cause of thousands of lost grades every single year. You can find out exactly how to decode those tricky instructions in our next explainer command words that decide the mark band. Don't let all your perfect knowledge go to waste. I'll see you there.